In this video, I'm going to explain about orthogonality in complex functions. So we have seen the orthogonality of two vectors, orthogonality of two signals, and also orthogonality of n mutually orthogonal functions. Now let us see the orthogonality of complex functions. For example, if you take the signals f1 of t and f2 of t, so these two are complex functions of real variable t. Then f of t can be approximated by c1 to f2 of t over an interval t1 to t2. That means f1 of t, which is nothing but c1 to f2 of t. Here, if you find out the value of c12 for complex functions. So how to find out for complex functions? If it is a normal signals means we have seen already the component value. If it is a normal signals, the two signals are f1 of t and f2 of t. But how to write the equation? Integral t1 to t2 f1 of t f2 of t into dt divided by integral t1 to t2 f square of t into dt. Right? F square of t into dt. So this is the normal component value of two signals. So here we are taking the complex signals. So that means one signal is f of t and f2 of t signal is a complex. So for complex type of signals you have to put conjugate f1 of t into f2 of t conjugate into dt divided by here f2 of t into f2 of t conjugate into dt. Now here what is f2 of t, f2 conjugate of t? Here f2 conjugate of t is a complex conjugate of fe of t. So for example, if you see the two complex functions f1 of t and f2 of t are orthogonal over an interval if. So when the two signals are orthogonal based on the interval t1 to t2, that is nothing but if this component value is 0, if you multiply these two, that means 0 into this whole term is what? 0. Then what is the equation? Integral t1 to t2 f1 of t f2 of t conjugate into dt is equal to 0. Or you can write the equation f1 of conjugate into f2 of t into dt is equal to 0. Now, so these two complex signals are orthogonal to each other. If you take a set of complex functions, that means those complex functions which is represented as g r of t, which is in the set of g r of t. Here r is equal to 1, 2 and so on 3. These are mutually orthogonal over an interval t1 to t2. So if these two are mutually orthogonal, that means if you take a set of complex functions, so how to write the equation? That is t1 to t2 integral gm of t gn conjugate of t into dt is equal to 0. If when these two complex signals are orthogonal, if m is not equal to n, if m is equal to n means we can get km. That means m is equal to n. So in place of n you have to substitute n. So this is the set of complex functions formula. So there are some problems on complex functions also. There is a problem I have to say. I have uploaded already, that is complex signals are orthogonal or not. So exam point of view, orthogonality problems are very important. One problem is based on is sine and cos signals are orthogonal. One more type of problem is complex signals are orthogonal. So you have to verify in my previous videos. Those are very important for exam point of view. Thank you.